You've probably heard, or seen for yourself, that the bottom pockets of stacked dryers aren't used as often as the top pockets. So why do manufacturers keep making stacked dryers, and why do laundromat owners keep buying them? The idea behind stacked dryers isn't just turns per machine, it's more importantly about revenue per square foot. 2 dryer pockets in the space previously used by just one, you've doubled your drying capacity without needing more available floor space. So even if bottom pockets of stacked dryers get used less, you are increasing your revenue potential because you can serve more customers on your busiest days. Stacked dryers are a space efficiency win, so if you want to make the most of every square foot, stack them up. Gas or electric? If you're setting up a laundromat, this is a big decision. If you're new to the industry, this might seem overwhelming. So, let's break down which one is better and explain why gas usually wins. Both types of dryers spin clothes and blow in hot air. The difference? Gas dryers heat the air using a burner, while electric dryers use heating coils, kind of like an electric stove. And just to be clear, gas dryers do need electricity to function. The difference is that in this debate, we're only talking about the heat source, not whether or not the dryer itself needs electrical power. Gas dryers are almost always more efficient for a laundromat than electric. They heat up faster, dry clothes quicker, and use less energy overall. That means lower utility costs and happier customers who don't have to wait forever for dry laundry. Here's where electric dryers really struggle: power requirements. A typical commercial gas dryer runs on 120 volts, 15 to 20 amps, basically a normal outlet, or sometimes 208 or 240 volts, single phase 7 to 15 amps for larger ones. No big deal. But electric dryers, they are a whole different story. 208 or 240 volt, 3-phase, 87 to 91 amps. That's a massive amount of power. For reference, the average home in the US has 100 to 200 amps total for the whole home. Imagine trying to power multiple electric dryers in a laundromat. You'd need to upgrade your entire building's electrical system. And with higher amperage, you also need thicker, more expensive electrical wiring. That adds up fast. Bottom line? Gas dryers win almost every time for laundromats. They're faster, cheaper to run, and don't require expensive electrical upgrades. Electric might work for a home setup, but for commercial use, gas is the way to go. What's the difference between single direction and reversing dryers? Single direction dryers spin in one direction, typically clockwise, for the entire cycle. Reversing dryers change direction at regular intervals, switching between clockwise and counterclockwise. Because single direction dryers spin in the same direction the entire cycle, they can cause loads to clump together, especially larger items like sheets and blankets. Some people even have a name for it: the laundry burrito. Ever pulled out a big tangled mess with wet laundry stuck inside? That's the problem. Reversing dryers help prevent laundry burritos. Because they change direction every few minutes, the load moves more freely. That means less tangling and clumping, better airflow, and more even drying. Because reversing dryers keep clothes from clumping, they dry loads faster and more evenly. This means lower energy costs, less wear on linens, and happier customers who don't have to restart cycles just to get their laundry fully dry. There are other hidden costs with single-direction dryers. When a dryer creates a laundry burrito, what do customers do? They stop the dryer, open the door, and shake everything out. But every time they do that, hot air escapes, forcing the dryer to reheat once they restart the cycle. That's extra energy wasted. And that hot air escaping, it doesn't just make the dryer work harder, it makes the air conditioner work harder too. Reversing dryers eliminate these problems by keeping items from clumping in the first place, saving energy on both drying and cooling. So why doesn't every laundromat have reversing dryers? The technology has improved a lot in recent years, and more laundromats are starting to use them. They cost a little more upfront, but the long-term savings make up for it. Bottom line, reversing dryers are just better. They dry faster, tangle less, and save energy, lowering utility costs. Some laundromats charge for dryers in quarter increments, while others use one set price for a full cycle. But which one actually makes sense? Let's break it down. Quarter pricing is a holdover from the past when dryers used mechanical timers. Customers would drop in a quarter, turn the knob, and the dryer would run until the cog reached the next stop. It worked back then. But today, if your pricing is set properly, 1/4 doesn't buy enough drying time. That means customers either keep feeding the machine or leave with half-dry clothes. Not a great experience. That's why total cycle pricing is the better method. Instead of small-time chunks, you set one price for enough time to fully dry a load. If someone needs more time, they can top off the cycle. Here's where it gets real: cool down time. For safety, dryers stop heating in the last 1 to 2 minutes of a cycle. If you're buying time in small chunks, you're paying for that cool down time over and over again. A full cycle means just one cool down period, so more time actually goes toward drying. And you know customers, if the dryer stops, what do? Open the door to check their clothes, then close it and add more time. Every time that door opens, heat escapes. Now the dryer has to work harder to get back up to temperature, and on top of that, your AC has to work harder too, raising cooling costs. Total cycle pricing stops waste and saves money for both the customer and the laundromat. Technology has come a long way, and laundromat pricing should too. Total cycle pricing is just better. It dries clothes properly, reduces customer frustration, and maximizes efficiency. If your dryers still run on quarter increments, it's time for a change. We all know dryers make lint, but where does it actually come from? When clothes and other linens tumble around inside a dryer, the heat, air, and friction cause tiny fibers to break off from the fabric. These loose fibers get carried through the dryer and pulled into the lint trap. The bigger and bulkier the load, the more lint you'll create. And if you overdry your laundry, extra heat and friction break off even more fibers, which means even more lint. Some newer commercial dryers have built-in technology that helps limit overdrying. Check with your equipment distributor or manufacturer to find out if they offer these features. Now that we know where lint comes from, what can we do about it? Clean your lint screens often, ideally after every dryer cycle, and do what you can to help customers avoid overdrying. You'll dry faster, save energy, and help prevent dryer fires.